Hey everybody, Mr. Schultz here back with you for lesson 716 or CCA2 textbook. So we've talked about radians. We did that last lesson. That's really just based off our radius. We've talked about cosine. We've talked about sine. We're going to kind of bring all these things together and use it around the unit circle. There is something here that I can spell. Unit circle. Kind of see how all these things relate. So let's take a look at. So there are some angles for which you know the exact values of sine and cosine. In other words, can you find exact values without using a calculator here? Well, okay, we'll just entertain them for this. I don't think you have to go super deep dive on here. But if I think about a triangle, and there's one triangle that exists here, and it's kind of a weird one to think about. It's more just like you have to think about it with just like your head. The triangle that's at 0 there has a height of 0. And if it's a unit circle, that means that it's got a radius of 1. And that if there's nothing in the height, that means that there has to be 1 in the length there. So that'd be at 0 degrees or 0 radians. 0 radians. That would also, that one we know. The cosine is going to be 1. The sine is going to be 0. Sweet. Same idea here with our 90-degree triangle. 90 degree, except we're going to have the opposite now. Our left and right movement, our x value is going to be none. Our height is going to be 1, and our hypotenuse would also be 1. Same thing, but the opposite. Now our sine is going to be 1. Cosine is going to be 0. There are other measurements here that you could start to work out, but just see it out on the next problem. I think it'll make a little bit more sense. All right, so we're going to build this unit circle using this resource page, which is just this thing right down here. What's going to happen is we're going to mark all these points on the unit circle, which notice that's in pi over 12. So we're talking about radians here because remember 1 pi radian, so 3.14 radians is a full 180. So remember that pi is equal to 180 degrees. This is in radians. This is in degrees. Again, just trying to make that connection for you between the things you should know and starting to acquire this radians thing. So as we can see, it's going to build up and get bigger. So it makes sense that, oh, well, this probably is pi over 12 because it's the smallest. My next smallest would be pi over 6, pi over 4, pi over 3. Then we've got 5 pi over 12. And then, of course, they don't have this listed, but that'd be pi over 2, would be at 90 there. And then we just keep on going. So I'm going to write the rest of these in, and I'll bring it back. Okay, so I went through and labeled the rest of these. 7 pi over 12, 2 pi over 3, 3 fourths, 5 6, 11 twelfths, and then, of course, pi radians again. That goes back to that 180. That will go in halfway around a circle. That'd be 180 degrees. Okay, so we've got them all lit. So find and label the exact coordinates in XY form for 3 of the points shown in the first quadrant. So here's our first quadrant. So we're going to look at those. I'm going to choose 3, and I'm going to choose these 3. Pi over 3, pi over 4, and pi over 6. And most reason why I'm choosing those is because those are kind of like the most common. Pi over 12, I would say, is a little bit less common, but definitely pi over 3, pi over 4, and pi over 6, you can use that a lot. So let's see what we can do to find those XY coordinates for pi over 6. We'll start with that. Okay, so let's take a look at our first one here, which is our pi over 6. So I'm going to draw this angle here. We know it's a unit circle, so we know our hypotenuse is 1. And then remember, we need 2 things. We need two things. So we've got a hypotenuse, so we need either the angle or we need this height. Well, or this length here, but that's what we're looking for. We're looking for the height or the length, or we're looking for what the sine or the cosine is. But guess what? We know what this angle is. It's pi over 6. Remember, that's in radians, and radians is like a degree. It's like the angle. So I know what pi over 6 is. That's in radians. So if we're going to find the sine, which is going to be the y or the height here, I'm just going to drag this triangle out here and redraw some stuff. I'm looking for that y or that y value or that height, but I know that this angle is pi over 6. So what I'm going to do is I'm going to go into my calculator and I'm going to sine of pi over 6 should be equal to y over 1. So really, what that means is just sine of pi over 6 should be equal to y. Now, let's be careful with this when you type this in your calculator. Punch this in and then pause the video now, punch this in, see what you get, see if it's the same answer as mine. Okay, so if you did that and you did sine of pi over 6 is equal to y and you got this number, you got something like 0.009138, you actually did it wrong. And here's why. You did that in degrees. You need to be sure that you're working in radians because pi over 6 is in radians. So if you put this into radian mode, if you put your calculator into radian mode, then you would end up with this number, 0.5. And that's your answer that you're looking for. So the sign here, what this says is that my height on this triangle right there is 0.5. That is what the y measurement is on that coordinate, is 0.5. Now once I've got that, then I can do the same idea. I can do the cosine of pi over 6. It should be equal to my x value. So same thing. I'm going to do the exact same thing, except this time I'm going to find the cosine. And again, if you have this in degrees, you'll get something like 0.999999. Remember, it's not in degrees. We are looking for it in radians. So in radians, then you should get some sort of a decimal equivalent would be like 0.866, so on and so forth. But there's another way to see this that's a little bit more exacting. Let's see what that looks like. So if I go back to Pythagorean theorem and I think about this triangle and I've got these, I'm looking for this x value. Well, I've got 2 out of the 3 sides. I can just do Pythagorean theorem. So 1 squared should be equal to 1/2 squared. That's the weirdest looking parenthesis of all time. Here we go. 1/2 squared plus x squared. 1/2 squared, that's just 1/4. 1 squared, that's just 1. X squared, that's just going to be that. We're going to subtract. I've got 3/4 is equal to x squared. Now I'm going to take the square root, so I'm going to end up with the square root of 3 over, well, the square root of 4 is just 2. Here is what my x side length is. So in numbers, it is this 0.866 thing, but the more exacting way to say this number without having to do the decimals, square root of 3 over 2. Square root of 3 over 2. So that is going to be pi over 6. So this is for pi over 6. That is one of our 3 measurements here. Will be those 2 things there. So I'm going to erase to make some space, and I'll do the next 2 much faster. Let's see what this looks like. Okay, so in summary here, pi over 6 is just really just saying what's the sine of pi over 6. You'll get that at 1/2 or 0.5. Cosine of pi over 6, you'll get that square root of 3 over 2. That's really all that we're doing. So now we got to do the exact same thing, but this time we're going to do it with pi over 4, and we're going to do it with pi over 3. So I'll let you do those 2, and then I'll show you the answer here in just a second. Okay, so here's where we landed. We've got this square root 2 over 2 for both sides in the 45-degree angle, and then we've got those exact same 2 numbers of square root of pi, or square root 3 over 2 and 1/2, but just flipped for this. Here's one thing that I'll call out here because you might be having a question about this. Why is 1 over square root of 2? Why do we write this as square root of 2 over 3? There's a bunch of different reasons why. Some of it's just kind of some old school like kind of carryover stuff. But just generally speaking, we don't leave a radical sign in the bottom of a fraction because it can be hard to set up a division problem with an irrational number. So we take that 1 over square root of 2, and all we do is say let's multiply by a giant 1, square root of 2 over square root of 2. Well, square root of 2 times by square root of 2 is equal to 2, and square root of 2 times by 1 is square root of 2. So it's the same thing. It's just being multiplied by that square root of 2, that giant 1 that we see here. So, okay, so that's that. This is a long problem here. So we just went and we found all those. Mark all their points for the unit circle that you can find exact coordinates. Well, guess what? This triangle here that we just did, that triangle just flips over to that side. It's the exact same thing, except that our x value here is just going to end up being a negative value, because guess what? It's in the negative region on the x's. The y is still going to be positive because it's still going up, not pi. This is going to be 1/2. And then you can do all the same thing with all of the other measurements. So you've still got this length of 1. You still got all that stuff. just ends up being negative. So based off the different quadrant that you're in, if you're down here at this one, then your y value is negative, but your x value is going to be positive again because you're in the positive region. We'll see more of this in a bit. If that part did make a ton of sense, that's perfectly okay. Last thing, if you've not done so already, label each angle with its radian measure. We did that. So we're going to move on to our next part. Okay, the rest of this is really just heavy, like calculator work. Again, make sure it's in radian mode, not in degrees, because you'll get off here. But we're going to focus on the angle pi over 12. That's that one that we skipped. And what are the coordinates at this point? Well, simple. We're just going to say sine of pi over 12 and cosine of pi over 12. So when you do that, your cosine comes first. You would end up with 0.97 as your x value, and you'd end up with 0.26, your cosine value, as your sine value there. Okay, now, so that was that pi over 12, so that's this angle right here. And it says use this information found in part A to determine each of the following each of the values here. This is all just calculator. Just plug this stuff into your calculator, see what you come up with. Hint here, you've got a negative, so guess what? I'm going to go down. I need to go backwards 1/12 pi. So guess what? It's going to be the same thing as what I had. Well, I'm just doing the problem now, but we will see that. It's same idea, but I'm just going backwards. So this value, I just moved down in the y values. I moved down by that negative 2.6. So let me just show this here. So this was up 0.26. This just moved down 0.26, that x value that we had right there. Next two answers, this is just calculator work, and end up with a negative 0.97. Because if I think about what's 13 pi over 12, well, 13 pi, well, so over 12, so 12 over 12 would be 1 pi. So I went all the way around, but then I went down again by that 1/12. But if I look at where I am again, instead of going forward by 0.97, I'm going to go backwards. I'm going to go into the negative land. So it's negative 9.7. Let me just rewrite this here so that it's just a little bit cleaner here. Negative 9.7. Then the challenge, find the cosine of 7/12. Okay, well, 6/12 would be halfway, so I know that it's got to be one more than that. So I've got my 7/12 here. Here's my new triangle here. And again, I'm just going to plug it into my calculator. And guess what? Again, I'm going to get that negative because I'm moving backwards on my coordinate plane. I'm moving backwards here. Negative. Let's see. Let's go 0. Let's take this negative out. Need to change this. Let's try this again. Too small, but this will work. 0.26, but it's negative. I'm going backwards in the x direction that way. And notice how that number relates to this, just like we found when we were doing that pi over 3 versus that pi over 6. We found that the cosine and sine things kind of flip-flopped. We'll see that same pattern happen with other side lengths as well, or with other sizes as well. Okay, now we're getting into some changes to our ideas here. So for A9, this is our last problem. It says for angle alpha, this is the Greek letter A, which is said alpha, is in the first quadrant. So if I draw my graph, it's in the first quadrant, and the cosine of alpha is going to be 8 over 17. So if I'm to draw this, I'm just going to draw a random triangle here, and it's 8 over 17. Well, cosine, that'd be my x value, and my hypotenuse is 17. Use that information to find the following values without using a calculator. So now I need what's the sine of alpha. So what I'm looking for then is what is my y value? What's that height? Okay, well, this is just Pythagorean theorem. So I'm going to set this up and solve this. Okay, so 17 squared is 289. 8 squared is 64. Just going to do some basic algebra here. Take that off. 225. You might recognize this one. Take the square root. I should end up with 15. Something that I might point out here is that in theory it's plus or minus 15, but because I know it's in the first quadrant, I know that my value can't be negative, so I am just dumping that answer. So it tells me that my sine is going to be 15 over 17. That's what sine of A is going to be, okay? Now my second one, pi, okay, pi radians plus 7, or plus alpha, which I know that alpha is 15 over 17. So all I'm really doing is rotating this triangle 180 degrees. It's going to be the same triangle, but just rotate 180 degrees. So guess what? My y value is just going to be negative. Same value, but it's just going to be a negative number. Okay, now I've got 2 pi. Well, 2 pi is just a 360. So I'm starting from 360, which is the same thing as 0. But this time I'm going to take away alpha, okay? So if I'm taking away, now my triangle is just going to be back here because I went full 360, and then I went backwards by alpha. So all I know here is that, again, my y value is going to be negative again. So I'm going to end up with another y value that is negative. But hey, check this out. Cosine. I actually got had by that the first time too. So so I'm going back here to take my 8 and my 17. Since I'm in quadrant 4 now, they're both positive. So this correct answer should be 8 over 17 positive. All right, that's everything. That's everything that we got for today. Have the rest of your day.